So we have done three types of hybridization: sp3, sp2 and sp hybridization. Generally in class 11 only sp3, sp2 and sp hybridization required. That's why these three hybridization I have given. But there are some hybridization in which d orbital is also involved, like dsp2 hybridization, d2sp3 hybridization. That type of hybridization also you will get in class 12. So here only sp3, sp2 and sp hybridizations are required. And as I have told you, carbon in its compounds always shows three types of hybridization, either sp3 or sp2 or sp. Single bonded carbon undergo sp3, double bonded carbon undergo sp2 and triple bonded carbon undergo sp hybridization. So you have got, when a carbon undergo sp3 hybridization, then the structure of the compound you will get tetrahedral, and the bond angle of the compound you will get 109.5 degree. When some atom undergo sp2 hybridization, then the structure of the compound you will get triangular, is a planar structure, triangular planar, and angle you will get, bond angle you will get 120 degree. And when some atom undergo sp hybridization, then the structure of the molecule will become linear. This is also planar structure, and the bond angle you will get 180 degree. So this thing you have to know, then you can find out the structure, also the bond angle present in the compound. Now, so in case of carbon compounds, as I have told you, if a carbon is single bonded, you can find out the hybridization directly sp3. If carbon contain double bond, directly you can say sp2. If carbon contain triple bond, then directly sp hybridization. Directly you can find out. But if some other molecules are given, suppose you want to find out the hybridization of phosphorus, generally central atom, I mean the atom which is present at the center, that atom undergo hybridization. So here phosphorus undergo hybridization. So what type of hybridization shown by phosphorus? That single bond double bond concept is not applicable for phosphorus. Single bond double bond triple bond concept is applicable only for carbon. Similarly, this is one of the ion which is called sulfate ion. What type of hybridization shown by sulfur? So if you want to find out the hybridization state of the central atom, to find out this, there is a formula, and if you know the formula, then you can find out the hybridization state of the atom. So now I will give you formula for predicting hybridization. If you know this formula, then you can find out the hybridization state. The formula is H is equal, H means hybridization, half of number of valence electrons of the central atom in free state or in ground state minus number of monovalent atoms. Mono means single, monovalent means single valency, I mean those atoms whose valency is 1, they are called monovalent atoms. Number of monovalent atoms surrounding the central atom, minus charge of cation, plus charge of anion, and the square bracket you have to close here. I mean half of number of valence electron of the central atom in free state minus number of monovalent atoms surrounding the central atom minus charge of cation plus charge of anion. So in short form, you can learn this formula like this: half of valence electron minus, sorry, it should be plus number of monovalent atoms minus charge of cation plus charge of anion. In short form, you can learn the formula like this way. Now, after putting the value of valence electron, monovalent atom, charge of cation, charge of anion, then you will get the value of H, and from the value of H you can find out the type of hybridization. For example, if H value we have got 2, suppose after putting all the values H value comes 2, then the hybridization is sp. If you get 2 value, hybridization always sp. Similarly, if the H value is 3, then hybridization is sp2. If you get 4 value, hybridization will be sp3. If you get 5 value, hybridization will be dsp3 or sp3d. You will get later what is the difference between dsp3 and sp3d. If you get 6 value, then the hybridization may be sp3d2 or d2sp3. You can find out it. Similarly, if the H value is 7, hybridization will be sp3d3. So based on the H value, you can find out the type of hybridization, whether it undergo sp, sp2, sp3 or dsp2, like that. Now I'll take one example, then you can understand about this. So first thing, as you know, methane, already you have drawn the orbital diagram. In methane, carbon undergo sp3 hybridization. So we'll take the example of methane and I will apply this formula. So methane is CH4. Here who is central atom? Carbon is said to be central atom because it is present at the center, and hydrogens are present in the surrounding, that's why they are called surrounding atoms. So when you apply the formula, half of valence electron of the central atom, our central atom is carbon. Carbon contain how many valence electron? Carbon atomic number is 6, 2, 4. I mean it contains 4 valence electron, plus number of monovalent atoms surrounding the central atom. Here surrounding the central atom, which atom is present? Hydrogen. Your central atom is carbon, surrounding atoms are hydrogen. And what is the valency of hydrogen? As you know, hydrogen valency is 1. I mean hydrogen is monovalent atom. So how many monovalent atom present? 4. So you have to write 4. That is called number of monovalent atoms surrounding the central atom. So if your surrounding atoms are oxygen, oxygen valency is 2. So that means there is no monovalent atom. Then you have to write 0. So how many monovalent atoms are present in the surrounding, that you have to write here. Minus charge of cation. Is there any positive charge? No positive charge, so charge of cation 0. Plus charge of anion. Is there any negative charge in the molecule? No charge. So ultimately you will get half of 8. That means you will get 4. I mean your hybridization is sp3. In methane, carbon undergo sp3 hybridization. So similarly you can apply for this type of ion also. If you apply half sulfur, your valence electron 6, here oxygen is surrounding atom, so monovalent atom is 0, no surrounding atom is monovalent, oxygen valency is 2, you know, minus charge of cation, no positive charge, plus charge of anion is 2, I mean 2 minus, so half of 8, that means you will get 4, I mean sulfur undergo sp3 hybridization. So by applying this formula, you can find out the type of hybridization for different molecules for different ions also. Thank you.